Hello guys, so we are back again and today we are going to start an important topic. Okay, although we have means I am not doing inequality between AM, GM and HP topic. Okay, we will do it later because there is one separate chapter. Okay, in Singlish for doing that. Okay, so we will continue with the series thing. Okay, when we are done with this chapter progression and series, then we will continue that. Okay, further on today we are done with our HP, AP, GP. Okay, in AM, GM and HM we have also done that. Okay, all the properties we have done. Okay, your AM, GM and HM should be very strong, and same goes for AP, GP and HP. Okay, further on today we are going to start with AGP, orthogeometric progression. Okay, so the main thing is we will do a derivation. Okay, for your understanding, although derivation is no needed. Okay, but I am doing it just for if someone wants to get understand derivation. Okay, so I am doing it. There is no strong I will recommend to learn derivation. Okay, and the formula which appears after derivation. Okay, so arithmetic geometric progression. Okay, arithmetic mathematico geometric progression, geometric progression. Okay, so which is we will denote it further by AGP. Okay, so these questions are very important. As the name suggests, it is a combination of AGP, AP and GP. Okay, further on let's derive it. What AP? How we consider terms in AP? A plus D, A plus 2D. What is the last term? A plus n minus 1 into D. We know this. Now consider GP. What is the first term in GP? R square, R cube till what is the last term? What is the last term? R power n minus 1. Okay, so now the sequence which will appear, just multiply this. Okay, just multiply this and see what you are getting. Okay, now what is the multiplying order? Okay, that is very important, you should know. Okay, you will not multiply. Okay, you will not multiply this term. Okay, you will multiply the rest of the term. Okay, just leave this term. Okay, okay, so we are going to continue. Okay, just leave this term. Okay, this A term. Okay, and multiply the rest of the terms, like leave this term, multiply this term with this with this and so on. Okay, like this, then you will get a S. Okay, what you are getting? A plus D into R, A plus 2D into R square and so on. What you are getting in the end? n minus 1 into D into R power n minus 1. Okay, you are getting this. Okay, in the end. Okay, now what we can do? Okay, the second step is very important step. Okay, and you should be very alert with and do that step. Okay, the first step is create AP. Second, consider a GP. Leave this first term, multiply the rest of the terms. Okay, now what is the next step? The next step is call it as A and multiply this by the common ratio of this series. What is the common ratio? What is the common ratio? Common ratio is R. Multiply this A by R. What do you get? R into S is nothing but AR plus A plus D into R square, A plus 2D into R cube till so on. What is the last term? A plus n minus 1 into D. Okay, R power n. Now consider it as B. Now remember, just the third step is very important. Okay, call it as B. Okay, first step is what? Creating a AP, considering a AP. Second step is considering a GP. Remember, don't take AR square. Okay, take R square, R cube till R power n minus 1. Okay, further on, then multiply them, leaving the A term, multiplying you will get this S. Okay, then call it as A. In the second step, multiply the S with a common ratio, okay, which is R. Then you get B. Now subtract A minus B. What you are getting? S minus R into S is nothing but A. This will subtract with this one. Okay, and what you will get? D into R. Okay, this will subtract with this one. Again you will get D into R square and so on. Okay, this last term, okay, will be left Before that will be a n minus 1 into r power n minus 1. Okay, so what you are left with, d into r power n minus 1. Then here will be this term, which is a plus n minus 1 into d into r power n. Okay, now what we can do, this is a GP. Okay, this is a GP. What you can do, just get the sum of this. Okay, get the sum of this. That is very easy using the sum formula. Okay, dr into 1 minus r power n. Now here many children do mistake, 1 2 3 4 till what term, n minus 1. So r power n minus 1 upon 1 minus r. Okay, after doing this, minus a into 1 plus n minus 1 into d into r power n. Okay, a plus. Okay, here what you have, 1 minus r into s. Okay, so you are getting this. Okay, this is when you move this 1 minus r down, what you get, s, which is the sum of this arithmetic geometric progression, and that is what you need to find. Okay, we want to find the sum. Okay, we consider AP, we consider GP, multiplied them, leaving the a term, we got a certain s, called it as a, then we multiplied the s by r. Okay, that is called r into s. After that we just got a second r into s. Okay, a series which we called b, and then subtracted a minus b, then we got this. The middle thing is a GP, so we calculated its sum. Okay, okay, now after calculating, if I move this 1 minus r here, what I am left with, 1 minus r here, dr into what, 1 minus r power n minus 1 into 1 minus r the whole square. Further on, a plus n minus 1 into d into r power n the whole upon what, r minus 1, 1 minus r, sorry. Okay, now this is the general formula of sum. Okay, I will recommend you not to learn this formula. Okay, okay, not to learn this formula, it is just useless. Okay, you don't need to learn, just follow the steps. Okay, they will teach you how to get the sum of AGP. Okay, never learn this formula. Okay, although I told you derivation just for your curiosity. Okay, nothing much. Okay, although you should just avoid. Okay, it just learn the steps. Okay, call the first given sequence. Okay, analyze the AP GP like this. After that, multiply the second with the common ratio, and then subtract them, a minus b, and then get the sum. Okay, this is the general approach. Okay, now let me teach you one more thing, then we will do some more things. Okay, now when we were studying AGP, remember, when we were studying GP, okay, remember GP, there was also one type of GP which was called sum of infinity. Remember, sum of infinity, where they specially mentioned that n tends to infinity. Remember, this was a type of GP. Okay, now further on, what we can say, if n tends to infinity. Okay, this can also be here if the GP tends to infinity, then okay, so in that case what we can do, then if we want to find the sum of infinity, then n should tend to infinity, then r power n will tend to 0. Same goes for r power n minus 1 will also tend to 0. Then let's see the modification which our equation which will have. Okay, so here you can clearly see this will become 0. Okay, this will become whole 0. Okay, what we are left with, nothing but a upon 1 minus r. Okay, dr, okay, plus dr upon 1 minus r square. Okay, so this is what we are left with. This whole thing will become 0. Okay, this will also become 0. Okay, so this is the sum formula for infinity. Although you can study this. Okay, although I will not recommend you to study this also. Okay, but it depends, because it is quite easy, but in the problem which we are going to do, we will not use formula any. Okay, we will not recommend you to learn any formula. Okay, we will do it by general process. Okay, so this was the formula. Okay, so you need to study this formula. Okay, although I am again telling, because there is no need. Okay, now let's move on. Okay, let's move on to questions. Okay, that are the very important. They will teach you more than this theory. Okay, theory doesn't give anything. Okay, they are useful in board exams. Okay, they are not useful in any other thing. Okay, now let's begin with the theories. Okay, the first question is, find the SN of the following orthogeometric sequence. Okay, so which is 1 comma 2 into 2 comma 3 into 4 comma 4 into 8 comma 5 into 16 comma 16 into 32 and so on. Okay, now don't consider it as an infinity. Okay, sum of infinity, that many children, until they have not mentioned it. Okay, they will specially write it, or they will show you, okay, by showing n tends to infinity, okay, or right here infinity, okay. These are the ways to tell you that it tends to infinity, or give you hint of mod r is less than 1, okay. That is also the condition of sum of terms in GP, which we have seen, okay. Sum of terms till infinity, okay. Now further on, now we will do these questions, okay, line by wise, okay. Now the first question which we are going to do is this question, okay. This question which we are going to do, okay. So the question is as follow. Let me call it as S, okay. I will call it as my S, okay. Wait a minute, okay. I will call it as S, okay. So we are going to use a blue pen, okay, because black pen will create problems, okay. It will be more good if we can use blue pen, okay. So we are going to start with solving the first problem. The first step was the given series, analyze it. Analyzing means what? Creating a simpler thing, okay. Generalizing the series, okay. I mean that, okay. How we can do these steps, okay. We will do with basics, okay. Okay, we will not go on any advanced, okay. We will do with basics. See how. First, whatever they have given, just write it, okay. Now how to write it, that is the very important thing. 1 2 into 2, 3 into 4, 4 into 8. Now you can see this is a AP, okay, while this is a GP, like this, okay. So this is 2, this is 2 power 2, this is 2 power 3, this is 2 power 4, this is 2 power 5. So that is your, you should observe the like this, okay. Observe the things like this. When the sequence is given, you should observe or think in like that way, okay. After doing this, what I will do, I will make my sequence, okay, simpler. How? 1 into 2 into 2, 3 into 2 power 2, 4 into 2 power 3, 5 into 2 power 4, like this, okay. Hope you have understand. 3 2, okay, sorry, 2 power 5, okay. Now the second step, okay. Okay, first step is finding, writing, analyzing, making the simple as, okay. The second step is you need to find the, now write the AP. What are the AP? AP is 1 2 3 4 5, right? Bus, that is more than enough, okay. Now A is what? A is 1. D is what? 3. 2 minus 1 or 3 minus 2, doesn't matter, 1, okay. Now we want to find the Tn term, okay. First Tn term of AP, okay. How you will get? A plus n minus 1, okay. Although I have told you the shortcut trick, nd plus t, okay, but we will do 1 plus n minus 1, okay, into 1, okay, which gives you nothing but n, okay. So this is our Tn term of AP, okay. Now we will write the GP. GP is what? Because here we want to find the Tn term, that is very important. So we will multiply AP and GP, then we will get the Tn term. So we are writing the AP and then getting its Tn term, writing the GP and getting its Tn term. So the GP is what? 1 2 2 square, 2 cube, 2 4. So analyzing the sequence is very important thing. You can easily say that its R is what? 2, and its A is what? 1. So can I get its Tn term? Very easily. A R power n minus 1, okay. We have used this formula thousands of times. So what we are going to do, 1 into R is what? 2 power n minus 1. So we got our Tn in GP, which is 2 power n minus 1. Now if I multiply this, okay, what I have? Tn of AGP, please write this AGP, okay, otherwise you will get confused between them. AGP is nothing but n into 2 power n minus 1. You can similarly found Tn minus 1 of this AP, Tn minus 1 of this GP, and Tn minus 1 of this AGP, okay. But there is no need, you can solve this problem by AGP, okay, by Tn term of AGP, okay. So further on, now let's again write the sequence, okay. So 1 into 2 into 2 square into 3 into 2 square, okay, 3 into, okay, this was only 2 square into 4 into 2 cube, and so on. The last term is what? N into 2 power n minus 1, okay. So I got this. Now I know its R will be same as this GPR, so R is nothing but 2, okay. The R is nothing but 2. So what I will do, I will call it as A, okay, like we did in solving when we were deriving the formula. Then we will multiply this by 2. 2s is nothing but 2 comma 2 into 2, okay, 2 square, 3 into 2 cube, 4 into 2 power 4, and so on. What will be the last one? N into 2 power n. We will call it as B. Now subtract these two. What you are getting? Minus s is nothing but, okay, A minus B. Always do A minus B, okay. I will write it A minus B. Always do this A minus B. What you are getting? Leave the 1. You subtract what? In this way, okay, in this way. 2 minus 1. This is nothing but 2 into 1, Okay, so 2 minus 1 is nothing but what? 1. 1 into 2, this is what? Every term will give me 1 into 2 power 2, then 1 into 2 power 3, until so on. What is the last term? Okay, will 1 into 2 power n minus 1, then here I am left with n into 2 power n. This term will remain as it is. Okay, and with a minus n. Why? Because we subtracted this one. Okay, so what you can see from here, what you can see, if I just write it again, okay, for your understanding, let me write it again. Where is? Okay, if I write it again like here, minus s is nothing but 1 plus 2 square plus 2 cube, okay, plus till what? 2 power n minus 1 minus n into 2 power n. Okay, after doing this, what you can do? After doing this 1 plus, okay, you can t 2 into 2 power what? How many terms are here? 1 2 3 4 till n minus 1. Okay, minus 1 upon 2 minus 1. Okay, so we are done with this thing, and what we are, sorry, n minus n into 2 power n minus n. Okay, so we are done with this, and what we are getting? 1 plus this is 2 into 2 power n minus 1 minus 1 into minus n into 2 to power n minus s. What it gives us? It gives us minus 1. Okay, minus this will become 2 to the power n. Okay, this will become plus 2, and this will become plus n into 2 to the power n. Okay, now it's up to you. You can simplify it further on, but I think I don't need to go on further on this. Okay, you can solve it after this. Okay, so this was this question. Okay, my objective was to teach you the basics. Okay, first get the Tn term, get the Gp term, multiply them, get the last term. Okay, get the common ratio, which is nothing but the G common ratio, and then multiply it, a minus b, then you get the what? Sum. Okay, by simplifying. Now let's do the second question. Okay, which is nothing but this. What is my main aim? First, analyze the sequence. 3, 7 into 3, 11 into 9, 15 into 27. I can easily see 3, 3 square, 3 cube, 3 power what? 3 power 4. Okay, like this. Okay, after seeing this, what is my purpose? Write it in simplified way. This is my second question. What is my S? 3 into 7 into 3, comma 11 into 3 square, 15 into 3 cube, and 19 into 3 power 4, and so on. Now I want to find the Tn term. Okay, I want to find the Tn term. How I can find? First I will write the AP. AP is what? 3, 7, 11, 15, okay, 19. Get the Tn term. Tn is nothing but 3 plus n minus 1. D is what? D you can get by subtracting 7 minus 3, which is nothing but 4. Okay, easy. Now what you can do? Into D, which is nothing but 3 plus, okay, 4n minus 4, which gives you 4n minus 1. Okay, so you got the Tn term of AP. Now write the GP. GP is what? 1, 3, here it is 1, 1, 3, 3 square, 3 cube, and so on. Okay, now can you get the Tn term? It is very easy. 1 into 3 power n minus 1. So you got the Tn term of GP also. Okay, you got this, you got this. Now you can get the AGP Tn term of AGP. Okay, AGP, what it is? It is nothing but what it is, 2 4n minus 1 into 3 power n minus 1. Okay, it is the Tn term of AGP. Okay, so you got the Tn term of AGP. Okay, after doing this, what you can do? Write the series again. Write the series again by writing the Tn term. Okay, what is the series? What is the series? 3, 7 into 3, 3, okay, comma 11 into 3 square, 15 into 3 cube, okay, till what? 4n minus 1 into 3 power n minus 1. Okay, so I got the Tn term. Now I should multiply it with the common ratio. What is my common ratio? CD is what? 3. I will multiply it 3s, call it as A. Okay, 3s. Okay, I will write it here. Okay, I will write it here. It will be very simple for me. Okay, then. Okay, so what we are going to do? Wait, did we did any mistake? Okay, no. So what we are going to do? This will be what? 3 into 3. This will be what? 7 into 3 square. This will be what? 11 into 3 power 3, and so on. What will be the last one? 4n minus 1. Okay, 4n minus 1 into 3 power n. We will call it as what? B. Okay, so we will call it as B. Okay, now further on, let's move on. Okay, so in the next step, what we will do, in the next step, what we are going to do, we will this 3s, okay, we will subtract. What is the next step? A minus b, as I told you before. So what it is, s minus 3s, what it gives me, it gives me, listen, this 3 will come here, this 3 has same, okay, they have same common ratio. Okay, this in gp, this gp will move common. Okay, this will subtract. Okay, ap term, okay, which will be what, 3 plus. Okay, now we are subtracting. Okay, but since it is greater, positive sign will appear. So 7 minus 3, which give me what, 4. So 4 into 3. Similarly here also 4 into 3 square. So now you got an idea that all the terms will be 4. Okay, now further on, what is the last term? Okay, this is the last term. Till here we will have 4 into 3 power n minus 1. Okay, 4 into 3 minus 1. And what is the last term? It will be in minus sign. 4n minus 1 into 3 power n. Okay, so we got this thing. Okay, after doing this, what we can do? We can do one thing, that simplify it. It is minus 2s. This is what, this is 3. Okay, and these terms, okay, they are forming a gp. So 3 plus what, 4 into 3 plus 4 into 3 square. Okay, 4 into 3 cube till so on, minus 4n minus 1 into 3 power n, and here 4 into 3 power n minus 1. Now I will take 4 common. This is my gp. I will take 4 common. 3 4. Okay, 3 also common. 4 into 3 I will take common, which will create here 1. Okay, here will be what, 3. Okay, here will be what, 3 square, and till how many terms, 3 power n minus 2. Okay, now what we can do in the next step, 4n minus 1 into 3 power n. In the next step, what we can do, 3 plus this will become 12. This is nothing but, okay, if I subtract 3 power n minus 1 upon 3 minus 1, this is nothing but 4n minus 1 into 3 power n. Okay, this is nothing but minus 2s. Okay, on further simplifying, what I get, 3 plus this will divide with this will give me 6 into 3 power n minus 1 into minus 4n minus 1 into 3 power n. Okay, minus 2s. Okay, further on, if I multiply with minus sign, then what I get nothing. Now this can be written as 2 into 3. 3 plus, if I write it 2 into 3, what I get, 3 power n minus 6. Okay, which gives me 4 and 3 power n. Okay, into plus 3 power n. Okay, so this is the final thing. Now if I simplify it, this minus 2 is here only. What I get, okay, this will become 3 power n. This will become minus 4n into 3 power n. Okay, this will become minus 3. Okay, further on here it is minus 2s, which gives me s is equals to nothing but what, 3 by 2 into 3 power n minus 2n into 3 power n plus, okay, this will become minus, this will become plus also, 3 by 2. Okay, so we are done with this. Okay, this is our solution. Okay, so what we can do in the next, okay, we are done with this problem. Okay, so this was all the things which you need to do, and now we are going to do the same thing continuously. Okay, so let's move on to the next question. Now the next question is what? The next question is this: find the sum of infinity of the following AGP. They have mentioned us that we want to find the AGP of infinity terms. Okay, that is important. That is what I was telling you, that they will mention. Okay, they will give you a hint. Okay, they will mention. Okay, now further on, the sequence given is what? 1 minus 3 by 2, 5 by 4, minus 7 by 8, 9 by 16, minus 11 by 32, and so on. Okay, now what is the next thing? I will write it. S is equals to 1 comma, and we will learn how to solve this type of problems. Okay, minus 7 by 8, 9 by 16, minus 11 by 32, and so on. Okay, so what you can do, get the common ratio, analyze this. Okay, analyze the thing. Okay, now in the infinity, we know the tn term will be infinity, so we don't need to find the tn or term or write the APGP thing. Okay, that step will be eliminated here. Okay, all we need to do is to understand the common ratio. Okay, and analyze this. Okay, now one more thing, what doubt you could have is that if I write the AP 1 minus 3 minus 5 like this minus 7, then minus 3 minus 1 will become 4 and 5 minus 3 plus will become 8. So it is not an AP. Wrong. What is the thing wrong here is never take this AP D as negative. Okay, that is the important thing. Okay, in this problem D you should not take negative. Okay, if the negative terms are written you should take R negative. Like here R easily understandable that it is nothing but minus 1 by 2. Okay, R is nothing but minus 1 by 2. So let me write the sequence again in more understandable way. This is nothing but minus, okay, nothing but 1 by 2. Okay, minus 1 by 2, and this is nothing but 5 into 2 square. Okay, and this is nothing but 7 upon 2 cube. Okay, this is positive. Okay, minus, and here it is nothing but 2 power 4. This is nothing but 11 power 2 power 5. When the odd power appears, the 2 is negative. Okay, so it is nothing but 2 power odd. Okay, so it is giving you negative. It is nothing but minus 2. Okay, minus 1 by 2, which is giving you negative at odd powers and positive at even powers. Okay, so always take R as negative. Okay, don't take D as negative. Okay, that is what this question was to teach you and I want to tell you. Okay, further on, what you can get is okay, we got the R. In this type of problem where infinity is mentioned, we don't need to find the Tn of AP, GP. Okay, so what we can do, we will directly multiply this R, we will call it as A, multiply this by what, minus 1 by 2, which will be minus S by 2, which is nothing but, I will write this, it will become minus 1 by 2, this will become plus 2 power 2, this will become minus 5 2 power 3, this will become plus 7 by 2 by 4, and so on. Now if I subtract them, they will add on, which will give me 3s by 2. Okay, minus into minus will become plus and will add on and give me 3s by 2. Okay, so this is my B, and what is the general process? A minus B. Okay, that is we do. Okay, so A minus B will give me what? A minus B will give me 3s by 2, which is nothing but, if I do this, okay, minus into minus will become plus, and minus 3 into minus 1 plus 1 will give me what, minus 2 by 2. Don't subtract this. Okay, further on this and this will minus, here there is no minus sign, so 5 will subtracted with 3 will give me what, 2 by 2 2 power 2 plus, here will be plus. Now here again this will become minus will give me 2 by 2 cube. Okay, and so on till infinity. Okay, so what we can do here, you can easily understand that it is a GP. Okay, this is whole is a GP, so I will do 1, I will take 2 by 2 common, don't subtract it. Okay, then what I am left with, minus, this whole will become 1. Okay, here it will become minus 1 by 2 plus 1 by 2 square and minus 1 by 2 cube, and so on till infinity. Okay, further on, now I can write it as 1 minus 1 into, this is nothing but 1 upon, this is what, common ratio is what, common ratio is nothing but minus 1 by 2, this is minus into minus 1 by 2. Okay, okay, further on what we can do, 1 minus, okay, 2 upon 3. Okay, so we are left with this, which will give me 1 by 3. Okay, so we got this thing, this is 3s by 2. If I move the 3s, what I get 2 by 9. Okay, so this is our answer. Okay, so what is the most important thing here, that you should always take R as common ratio as negative, don't take D as negative. Okay, this will create a problem, okay, in your questions of AGP. Okay, now let's move on. Okay, to the next problem. The next problem is as follow. It says 1 comma minus 4 by 2 comma 7 by 4 comma minus 10 by 8 comma 13 by 16 comma minus 16 by 32, so on. Okay, is what, sum, we want to find its sum. Okay, so what we can do, or most important thing is that we should analyze it like we told you yesterday before. Okay, just 2-3 minutes ago, sorry for yesterday. Okay, so here it is what, 1, this is minus 4 by 2, this is nothing but 7 by 2 square, this is nothing but minus 10 by 2 cube, this is nothing but 13 by 2 power 4, and so on. Okay, now considering about AP, you can say AP is 1 4 7, okay, 10. Don't say AP is what, don't say that this is AP 1 minus 4 7 minus 10. Wrong. This cannot be AP. I told you never take D negative in AP. Okay. Further on, what is your D? Common ratio. GP, what is common ratio of GP? Is nothing but 1 by 2, minus 1 by 2. Okay. Take the GP common ratio as negative, never take the D negative. That is the main thing which this question wants to tell you. After this, what you can do? After this, you understand that the common ratio is 1 minus 1 by 2. I will multiply this. I will call it as A. Infinite term, we don't find the Tn term of GP and HP, of GP and AP. What I am getting after multiplying? Minus 1 by 2. I am getting minus S by 2. 1 I will move here. Okay, minus 1 by 2. This will become 4 by 2 square. This will become minus 7 by 2 cube. This will become 10 by 2 power 4, and so on. If I subtract this, okay, this will become plus, which will give me what? 3s by 2. Right? Now what we can do, this one will come as it is. Okay, now minus into minus will become plus, and minus 4 plus 1 will give me minus 3 by 2. Similar goes for here. 7 minus, this will give me plus 3 by 2 power 2. Here minus 10 plus 7 will give me minus 3 by 2 power 3, and so on till infinity. What I am getting, 1. If I take minus 3 by 2 common, okay, we usually make the first term 1, then we are getting what? 1 by 2. Okay, minus, okay, this will become minus, will become plus 1 by 2 square. Okay, until so on infinity. Now this is sum of infinity terms, and this is minus 3 by 2. This will become 1. This will become 1 plus 1 by 2. Okay, minus into minus, the common ratio is negative also. The minus minus will become plus here, which will give me 1 minus 3 by 2. Here what we are going to do, is this will move up, this will become 3. Okay, you can easily see 1 minus 1 is equals to 0. Now if s is equal to 0, we are getting, okay, if we move it that side also, it is also 0. So s is equals to 0. So the sum is 0. It mostly happens in infinity GP. We have understand the reason of doing it. Okay, reason for why it is like that. Okay, the common ratio is the main reason. Okay, why this series we study. Okay, that also I have told. Okay, so s is equals to 0. You got the reason also why. Okay, I have told you the reason also. So we are done with these basic problems, which gives you a basic understanding of, okay, of AGP. Now let's move on to some good problems. Okay, this was just for making you comfortable in AGP. Okay, these problems were not tough. Okay, these problems will never be asked in your exam. Okay, let me get the questions which are of good level. Okay, the question is as follow. Okay, the question is as follow. The question says find the sum of the series to n terms. Okay, plus 1 plus 3x plus 5x square plus 7x cube plus till n terms. Okay, now you want to find the sum of this series. Okay, till n terms. Now what you know, it is not an infinity thing. First make the difference. Not an infinity. Okay, problem. You need to find the Tn term of AP and GP also. Okay, so first analyze. The common ratio is x. 1, 3, 5, 7 are in AP. I will write the AP. What it is? 1, 3, 5, 7. That is much enough. Get the Tn. Tn is what? 1 plus n minus 1. My D is what? 2, which gives me nothing but 2n minus 1. Now GP. Write the GP. 1 x, x square, so on. What is my Tn term of GP? Nothing but x power n minus 1. Okay, I got my GP Tn term. Can I get the Tn term of AGP? Very easy. Okay, 2n minus 1 into x power n minus 1. I got the Tn term of AGP. Can I write that? Can I write the series now? Yes, you can write s is equals to 1 plus 3x plus 5x plus 7x cube till what? What is the last term? 2n minus 1 into x power n minus 1. Okay, further on, now what the common ratio is x, so multiply by x, call it as a. That was also a step. So x into s is nothing but this one will become x, this will become x square, this is x square, this will become 5 into x cube, 7 into x power 4 till the last one will become what? 2n minus 1 into x power n. Call it as b. Okay, now if I subtract this, what I'm left with? S minus x into s, which gives me what? 1 will come as it is, this will become 2, 2x, this will become 2x square, this will become 2x cube, till so on. What is the last term? 2 into x cube power n minus 1, and here this will be minus x power n. Okay, now further this will become 1 minus x into s, nothing but if I take 2x common, what I'm leaving with 1 plus x square, until so on x cube power n minus 2. Further on this will be as it is 2n minus 1 into x cube power n. What it gives me? 1 plus 2x, this is nothing but, okay, 1 minus x power n minus 1 upon 1 minus x. Okay, now if you get confused at what should I take x, I should say take as if x is greater than 1, then what will I do? Will I write it x minus 1, x power n minus 1? There are two types of Sn formula in n term. Okay, remember if you have studied the GP, sum of n terms. Okay, there are two formula, a into r power n minus 1 upon r minus 1, a into 1 minus r power n upon 1 minus r. These were two formulas depending upon r is greater than 1 or less than 1. But here you can see it is forming 1 minus r. So the base should be same. So we will take what? 1 minus r power n minus 1. It will be suitable with your problems. Okay. Further on, so this is the thing which we got, 2n minus 1 into x power n. Now let's move on. What we are getting? If I move the s here, what I'm left with? 1 plus 2x 1 minus x power n minus 1 upon 1 minus x the whole square. Here it will be 1 minus x. This will be nothing but 2n minus 1 into x power n upon 1 minus x. So we are done with this problem. This problem was a good problem. Okay, the previous problem I given you in what sequence. Okay, now this problem is given in your series. Okay, like sum. Okay, so it is given in series, while those previous problems were given you in sequence. Okay, nothing different. Okay, the second question is as follow. Okay, this is just the series. Okay, series, sequence. Previous one was sequence, this is series. Okay, sum of infinite term of series. Okay, they are writing it also series. Okay, now I will analyze my AP. 1, 3, 6, 10. Tn is nothing but 1 plus n minus 1 into 2, which gives me 2n minus 1 again. Okay, this is basic thing. Okay, you will understand. Further on, my GP common ratio, GP is 1 minus x into x square. Okay, so on. What is my Tn? X power n minus 1. Okay, so we are done with this. Okay, but doing this is not useful in what? Infinite. Okay, infinite. If you are doing this, then you are wasting your time. Okay, please don't do it. I was doing just checking that are you doing with me. If you are doing it, then you are wrong. You have forgotten what I have told you. Don't do this. There is no point doing it infinite series, please. Okay, it is just it is just making you realize again that don't do this thing. Okay, they are not useful in infinite series. Okay, infinite series type problem. Okay, just write the problem. 6x square, call it as s, plus 10x cube till infinity. They are quite easy. Call it as a. You know the common ratio is x, multiply it by x. What you get? X, 3x square, 6x cube, so on till infinity. Call it as b. Do a minus b thing. What you get? 1 minus x into s. Now this expression is very familiar with you guys. 1 plus what you get? 2x 3x square. Okay, 4x cube, till so on till infinity. What you can see here, if I do one thing. Okay, now here common ratio is what? 2x. Sorry, common ratio is x. Now what you can do further on? Okay, and this is sum of infinite terms. Okay, what you can do? Think. Okay, so what we can do? Okay, so here you can see it is again a series. Okay, it is again forming a series. Okay, now let me call it as some p. Okay, this is nothing but 1 plus 2x plus 3x square. Okay, plus 4x cube until what? Infinity. Okay, now if I get the common ratio, I have common ratio as x, and multiply x into p is nothing but what? X, 2x square, 3x cube till infinity. What I'm left with? P minus xp is nothing but 1 plus x plus x square plus x cube till so on till infinity. Okay, till so on till infinity. Now what we can do, what we can do is a very simple thing. We will just get the p out of this, 1 upon x into p. This is nothing but a gp, infinite term gp. The first term is 1. You can do it using x common, but don't use it because in sum of infinite terms you can directly do from the starting. 1 upon 1 minus x. We got this. Now let's move on to the next page. Then what we are, this is the previous problem. Now what we are getting, 1 minus x, this, and what was p, 1 minus x into s, 1 minus x into s. This is what, 1 minus x already. So what we get, s is nothing but 1 minus x into the whole cube. So we got the s. So we got the s. Now let me explain you the whole problem again. If you have not understand, first find the sum of this. That question is very clear. Now what is the second thing? Second thing is that don't go for AP and GP because it is an infinite term problem. Now your doubt should be that I did it because just to make you realize again that you should not do this. Now if you observe clearly, this is what, I will make you understand this problem very clearly. This is 1, 3, 6, 10. If you do 3 minus 1 you get 2. If you do 6 minus 3 you get what? You get 3. If you do 10 minus 6 you get 4. Now if you see 2, 3, 4, if you do 3 minus 2 you get 1. If you do 4 minus 3 get 1. So terms which don't form a AP in the first attempt, and but the difference from a AP, like this, they can also be solved by AGP. Like here they are not forming an AP in the first, that is 3 minus 1, 6 minus 3, but when the difference is taken they are forming an AP. Same goes for the power. So this type of problem you can do by AGP again, but it involves 2 times. 2 times multiplication. Like here we did the first time, we multiplied by the common ratio, we got 1 minus x into s, we assumed it as some p, we got a series again. We got a series again, we multiplied it with the common ratio, subtracted it, we got a summation thing. And then we got our answer, we got the formula. So remember that difference can also be in AP. That type of problem is very common. Like this here they are not in series but not in AP, but after that their difference are in AP. You need to understand this thing. This type of problem is very general. You should be familiar with this type of problem. So we are done with this problem. To make you understand this point was very important, that the difference are in AP. And these type of terms whose terms are not in AP but the difference are in AP can also be solved by AGP. Further on, now let's move on to the next lecture, next problem. So the next problem is this. Find the value of 2 power 1 by 4, 4 power 1 by 8, 8 power 1 by 16, 16 by 1 by 32 till infinity. This problem is quite it is just make you scare. If you do some little modification you will come to know that it is a AGP. What modification? Just see. If I write SS, this is a sequence. 1 by 4, comma, if I write is 2 by 1 by, don't cancel it. If you cancel it then this question is going to be for sure wrong. 32 and so on till what? Infinity. Now the bases are same. Can I add them? Yes, easily. Then it is what? 1 by 4, 2 by 8, 3 by 16, 4 by 32 and so on till infinity. This property I have also told you that if it tending to infinity, the power when added it will also tend to infinity. When you are solving summation type problems. Remember, check the previous video if you don't know. So after this you can see that 1, 2, 3, 4 are in AP. Although you don't need to find the Tn term, remember that 1 by 4, 1 by 8, 1 by 16 are in GP with R as what? 1 by 2. R is 1 by 2. Please keep it in mind. R is 1 by 2. So we got this thing which is very important, that R is 1 by 2. After doing this, after understanding this that R is 1 by 2, what we can do? We can do one thing, that S which is our S, we will multiply it with what? 1 by 2. Okay, but remember, don't take it as this as s. Please don't do this mistake. Don't take it as s. Instead, what you do, take this power is AGP, not this whole thing is a AGP. Please take this as a p. Okay, some 1 by 4, 2 by 8, 3 by 16, okay, 4 by 32, okay, till what, infinity. Okay, take it as AGP. Okay, now find its sum multiplied by 1 by 4, 1 by 2. What you get? This will, when multiplied, what it will become, 1 by 8. This will become what, 2 by 16. This will become what, 3 by 32. Okay, till what, infinity. If I subtract this, what I get again, p. Okay, what I have left, 1 by 4. This will cancel with 1 by 8, cancel 1 by 16. Okay, what, 1 by 32, and till so on infinity. If you observe clearly, it is nothing but 2 power 2, 2 power 3, 2 power 4, 2 power 5, okay, till what, infinity. This is nothing but p by 2. I forgot to write here 2. Okay, so this is what, okay, 2 power 2. Okay, now let's move on to the next page. Okay, so we got our things. Okay, p by, if I cancel this 2, okay, what I'm left with, 1 by 2, 1 upon 2 square, 1 upon 2 power 3, till what, infinity again. Okay, so we got our p. Can I get its value? Yes. 1 by 2 into 1 minus 1 by 2. Okay, 1 minus 1 by 2. It is nothing but 2 by 2, which gives me what, 1. Okay, so we got our p value. But remember, our s was what? 2 power p, because we consider it as p. So our sum value is what? 2 power 1, which is nothing but 2. Okay, so that is this problem. Okay, you need to be very careful and alert and be conscious, okay, while attempting the problem, that this power is forming a AGP, not this whole. Okay, although we taken it as s, okay, because that is the s we need to find out. Okay, now let's move on to the next problem. Problem number 4. Okay, which is this, which says 1 square plus 2 square by 5 plus 3 square by 5 square, okay, 4 square by 5 cube till infinity. Okay, here you can now just observe this thing. Okay, the beauty, 1, 4, 9, 16, okay, and so on. Okay, now if you see these terms, okay, 4 minus 1, 3, 9 minus 4, again 5, 16 minus 9, 16 minus 9 is what, 7. Now the difference, if I take them, what I get, 5 minus 3, 2, 7 minus 5, 2. So they can also be solved by AGP, because their terms are not in AP, but after the difference they are in AP. Okay, they are forming in AP. So here we need to do twice use AGP thing. Okay, 2 times. Okay, we need to use 2 times. Okay, that is the important thing, you should be alert. Okay, now let's do it. Okay, so how we can do it? Call it as s. That is the basic general approach. 1 square by 2 square by 5. Here common ratio is very simple to analyze. The thing we should know that this will also be in AGP, but it will be it will use twice AGP. Okay, twice application of AGP these problems. So s by 5. Okay, this will become what, 1 square by 5. This will become by 2 square by 5 square. This will become 3 square by 5 cube. Okay, this will become 4 square by 5 power 4 until infinity. If I subtract them, what I am left with, 4s by 5. This is basic calculation. Here will be 1, here will be 1 by 5. Okay, here will be 1 by 5. What this will be, this will be nothing, 9 minus 4, which will be 5 by, okay, this is 4 minus 1. Okay, this is 9 minus, okay, 9 square, okay, let me just, 4 minus 1, this will be 3. Okay, this will be 3. This will be what, this will be what, 9 minus 4, 5 by 5 square. This will be what, 16 minus 9, 7 by 5 cube. Okay, till so on like infinity. Okay, now we know that this is not the end, we have to do AGP again. Okay, so don't get scared. Okay, in this problem we need to use AGP twice. Call it as P. What our P is, 3 by 5. Now it is more simple. Okay, you can easily understand this problem. 5 by cube till what, infinity. Now P is what, now common difference is what, 1 by 5. Okay, so if I multiply it by 1 by 5, what I am left with, 1 by 5 is nothing but 1 by 5, 3 by 5 square, 5 by 5 cube, until so on infinity. Now if I subtract this, again I have 4p by 5, but this is 1, this is 2 by 5, this is 2 by 5 square, 2 by 5 cube, till what? Infinity. Now what we can get its sum. If I take 2 by 5 common, because we will get 1, that was the reason. 1 by 5, 1 by 5 square, till what? Infinity. Now what I can get? 1 plus 2 by 5, this is nothing but 1. 1 minus 1 by 5, what we are getting? 1 plus 2 by 5. Okay, this is nothing but 5 by 4. Okay, this is nothing but 1 plus 5 will cancel out, which will give me 1 by 2, getting us 3 by 2. Okay, here what we have, if I substitute the p thing, what was p? 4 by 5 into 4s by 5. Okay, so what we are getting, it is equal to 3 by 2. If I calculate it, what I get? 3 by 2 into 16, okay, into 25 by 16, which gives me 75 upon 32. Okay, so we are done with this problem. Okay, so this problem was a double AGP type problem. Okay, and we will move on to the next question. Okay, these series thing are very important, it should be strong. Okay, because in exams, okay, these series questions are very important. Okay, now let's move on to the next problem. Okay, wait, let me get the problem. Okay, so the next problem is this. Okay, which tells you the sum to n terms of the series 1 square minus 2 square plus 3 square minus 4 square plus 5 square minus 6 square so on is dash if n is odd. Okay, so it is asking if n is odd. Okay, n is odd, then what its sum is, and if n is even, then what its sum is. Now if you, because I have solved so many problems, so I remember that we have done this problem already, but I am solving it again. Okay, so that you can revise it again. Okay, no other reason. Although I would have skipped this, but it will increase, just doing it twice, it will increase your concentration, your remembering power. Okay, so here if you observing the series, okay, is very crucial thing. Okay, you can observe that every what is the purpose of giving this odd, n is even, you should observe n is, if you observe n is always in this series is with negative sign, is always with negative sign, like minus 2 square, minus 4 square, minus 6 square. Okay, so if n is odd, it is always, n is odd, so it is always what? Is always with positive sign. Okay, positive sign. If you observe 1 square, 3 square, 5 square, it is always positive. Okay, now we consider the case 1. Okay, case 1, what? N is odd, then what is the case? The case is like this: 1 square, 2 square, 3 square, minus 4 square, and I will continue this. What is the last term? It is odd, it will be what? Plus n square. What will be the term before it? It will be shortly be even, n minus 1 the whole square. Okay, I know we can get this term sum very easily. Okay, how I can get the sum of this? If you observe clearly, what you can come to know that it is forming a square minus b square thing. 1 minus 2, 1 plus 2, like this. 3 minus 4, 3 plus 4, and so on. This will form with what? N minus, okay, this will form with what? N minus 2, n minus 2 plus n minus 1, and n minus 2 into minus n plus 1. Okay, like this, till what? N square. Okay, now you can see all these are becoming 1. Okay, and what we are getting? 1 plus 2 plus 3 plus 4 till what? N minus 2 plus n minus 1. Okay, plus n square will be left here. Okay, I have taken minus 1 outside. Okay, so this is still n minus 1 term, so I know the sum of n term is n into n plus 1 by 2. Here it is a minus sign. Okay, then what I will substitute? N I will substitute as n minus 1, my last term. Here it is n square. Okay, so minus 1 into n minus 1 into n minus 1 plus 1 upon 2 plus n square. What I get? Minus into n minus 1 into n upon 2 plus n square. Okay, this gives me what? 2. This will be with minus sign, will give me, okay, 2n square will become this, minus n square plus n upon 2 will give me what? N into n plus 1 by 2. Okay, so we got this thing, okay, which is nothing but n into n plus 1 by 2. Okay, that is very important. Okay, so we got n into n plus 1 by 2. Okay, so you need to be alert. Okay, so this thing is important. Okay, you should know. After doing this, we going to know that. Now let's move on. Okay, so we got for the odd. Okay, now for n is even. Now case 2. Now for case 2, n is even. N is even. Then what is this series? Okay, 1 square minus 2 square, 3 square, and so on till what? Plus, no, sorry, minus n square. Okay, if you observe it is again 1 minus 2, 1 plus 2, plus 3 plus 4, 3 minus 4, so on till what? N minus 1 plus n minus 1 minus n. Okay, now here minus 1 will move outside. Give me 1 plus 2 plus 3 plus till what? N term. And I know the sum of n terms is nothing but n into n plus 1 by 2. So my answer is minus n into n plus 1 by 2. So this is our answer. Okay. Although it is very clear that how two different answers are appearing in this question. Okay, if you observe the series. Okay, so we are done with this problem and we will move on to the next problem. Okay, let me get the paper. Okay, so the next problem is this is the next problem. The next problem is this. Okay, which says this is a advanced level problem. Okay, this will teach you one more thing. Okay, how GPP appears in problems, okay, of high level. Okay, now the problem is summation m is equals to 1 to infinity, double summation n is equals to 1 to infinity m square n into 3 power m into n into 3 power m plus m into 3 power n. Okay, is a options are given. Okay, option doesn't matter. Okay, so in the end you are going to analyze by solving. Okay, in this type of problems. Okay, so what we can do? So the first thing we can do in this type of problem is that bring this m and n down. Okay, so I can get some m and n. Okay, and then I can separate. Okay, in summations. Okay, so that is our main logic. 1 upon 3 power m. If I give one this m to this and n 3 power m plus m 3 power n, here if m by n. Okay, this will be m by n. Okay, so I have broken it. M I have given this and m into n and m into n, divided this. The whole it was with m into n. Okay, the summation will remain as it is, nothing much. 1 to infinity. Further on, what we are having, 1 upon this is nothing but 3m by m. This is nothing but n will cancel out, 3m upon m. Okay, this is nothing but 3n upon n. Okay, the summation will be as it is. I don't need to write it again and again. Okay, but you should write it. Okay, so 1 upon what I will call it. Okay, if I call, let 3m upon m be what? Some k. Okay, some k. Okay, and 3n be some p. Okay, some p. Then what we get? 1 upon k into k plus p. Okay, so summation n is equals to 1 to infinity upon summation n is equals to 1 to infinity m to infinity is nothing but I'm calling it just some. Okay, to make it easy. Okay, now it is some s. Okay, now if I substitute, replace x by m. Okay, this is a property of summation. If I replace x by r, if I replace x by p, the thing should be same. Okay, this is a probably property which I have taught you while teaching the properties of summation in the first lecture. Okay, the property just says that. Okay, sum n. Okay, it is a and the summation. Okay, a plus b. Okay, so if I interrelate it like b plus a, okay, replace it. Okay, then the sum will also be equal, like summation n is equals to 1 to n. The thing with a plus b, then with the thing with b plus a will be equal. Okay, that is the basic property. Okay, and it is true for always. Okay, so I will replace k by p and p by some other value. Okay, and see what I get. Okay, then summation m is equals to 1 to infinity, and this n is equals to 1 to infinity. it will become p, this will become p, this will become k. Okay, after this what we can do, we can this will get 1s also because it is same. Okay, if I add this, it is 1, this is 2. Okay, if I add this, what I get, 2s is equals to, summation will come outside, m is equals to 1 to infinity, n is equals to 1 to infinity. Okay, this will be what, okay, this will become what, I can take p plus k common. Okay, but let me write for your understanding, k plus p for 1 upon p into p plus k. Okay, so I have written this. Okay, now I will write this, not write this whole thing. P plus k I can take common, then what I am left with, 1 upon k, 1 upon p. Okay, so what we can do in the next step, we can do one small thing in the next step, that is this thing, which is nothing but 1 upon p plus k. Okay, if I multiply p plus k upon what, p into k, this p plus k will cancel out, giving me 1 upon p into k. Okay, and here will be two summations. Okay, and this will be 2s. Okay, now further on, if I resubstitute the p and k value, what I have, m is equals to 1 to infinity, n is equals to 1 to infinity. If I resubstitute it, what I have, 3 by m upon m, 3 by n upon n. Okay, now since it is in multiplication, I can bifurcate it into two summations. Okay, that is the property. So 1 to infinity, this is nothing but m by 3m, and this is nothing but n is equals to 1 into infinity n by 3n. Okay, now if I get the sum of 1, the other will be same. Okay, because they are almost same, so I will call it as some p, summation m is equals to 1 to infinity what, m by 3 by m. Okay, now if I open it, what I get, 1 upon 0, 1 for 0. Okay, for 1 I have 1. Okay, 3 for 2, it is 2 upon 3 square. For 2 it is, okay, for 3 it is 3 square, 3 cube, and for 4 it is 3 power 4 until what, infinity. Okay, now if you can clearly see, okay, you can clearly see why it is a AGP. Okay, it is a AGP. If I take 1 by 3 common, okay, 1 by 3 common, what I am left with, 1. Okay, this is 2 minus 2 plus 3. Okay, sorry, 3 plus 2 by 3 square. Okay, I was just doing the direct summation. Okay, sorry, 3 by 4. Okay, till what, infinity. I have the common ratio here is 1 by 3. Okay, so if I multiply this 1 by 3, what I get, 1 by 3 square, 2 by 3 cube, 3 by 3 power 4 till what, infinity. If I subtract this I called as a, this I called as b, then what is a minus b? A minus b is what, p minus p by 3. Okay, it is nothing but what I get from this. Okay, what I get is p by 3 will be here only, 1 by 3 will be here only, and this will cancel out with this. So what I am get, 1 by 3 square, 1 by 3 cube. Okay, 1 by 3 power 4 till what, infinity. Okay, now here you can clearly see it is a GP. Okay, 1 by 3, if I take common, 1 plus 1 by 3, 1 plus 3 square till what, infinity. Okay, so further on what we have, this is 1 upon 1 minus 1 by 3, which gives me nothing but 3 will cancel out, which will give me 1 by 2. Okay, and this will be what, 2p by 3. Okay, when I move it here, what I get, 3 by 4. Okay, so the p value which we need to find is nothing but 3 by 4. Okay, so we got the p value. Now if I resubstitute the p value, okay, what we had earlier, okay, we had this. Okay, summation m is equals to 1 to infinity 3 m by 3 by m, it is nothing but p. Okay, and this summation n is equals to 1 by infinity is nothing but some p. Okay, both will be same, so it will be p square, which is nothing but 9 by 16, and this is equal to 2s. So what we get, 9 by 32. Okay, so this is our answer. Okay, 9 by 32. Okay, so which is the C option. Okay, which is the C option. Okay, so we are done with this problem. Okay, now this problem was quite good because in between the problem AGP appears. Okay, and you need to be very conscious, okay, that it is a AGP, and then you have to solve it. Okay, that is the means it checks your alertness as well as your mindset during the exam. Okay, so this was a quite GE advanced level problem. Okay, now let's move on to the next thing. Okay, hope you have understand the reason why we took it to separate it, make a same term, okay, making it into some multiple time to break it into summations, okay, and then solve it. Okay, now let's move on to the next problem. The next problem is seventh problem. Okay, the seventh problem is as follow. Okay, which is nothing but that this problem is quite understandable problem. Okay, not, but it seems appears like complicated, but it is very simple problem. Okay, all you just need to be is very alert. Okay, so the problem is like this. Call it as S and open it first. Open it, otherwise you will get scared. 216 by 4, 215 by 4 square. So you can now see that it is a GP. Now here you cannot tell what it will be 4 power. Okay, so one thing, this question is that it is a AP. It is decreasing, so 2017, 2016, 2015 and like so on. So it will reach till 1, which they are telling. Okay, so there is no point. Okay, till n terms. Okay, they have not mentioned. So we want to analyze the AP. AP is 2017, 2016 and so on. Okay, so can you get the Tn term? Very easy. 217. N is what? 217. Okay, number of terms is what? 217 plus 217 minus 1 into D is what? Minus 1. You come to know that it is 1. Okay, Tn although you don't need to find because they have given, but the main thing is finding the 4 power. Okay, the GP is what? 1 by 4, 1 by 4 square till sum on. Okay, we want to find the T 2017, which gives you what? 1 into 1 by 4 into 2017 minus 1, which gives you 1 by 4 by 21016. Oh, 2016. Okay, so we got the Tn term of AGP 2017. Okay, nothing, doesn't matter of AGP. Okay, just you need to write the AGP. Okay, it is nothing but what, you know this, so it will be 1 by 4 power 216. Okay, before that will be what? 1 by 4 power 215. Okay, and like that. Okay, so can you write the S now? Yes, very simple. 1 by 4 by 2015 and plus 1 by 4 by 2016. Okay, so we are done with this. Now you came to know that it is 1 and here it will be 2. Okay, and so on. Okay, because it is decreasing. Now you know the common ratio, it is nothing but 1 by 4. So if I call it as A, the next will be what? S by 2. Okay, it will be what? S by 2. S by 2 equals to 217 by 2. Okay, sorry, 4. S by 4, 216 by 4 square, 215 by 4 cube, and what is the last term? What is the last term? It is nothing but 1 by 4 by 2017, and this is nothing but 2 into 1 by 4 by 216. Okay, now I will call it as B and subtract them. Okay, subtract them, what I get? Okay, I will subtract them and see what I get. What I get is S minus S by 4. Okay, S minus S by 4. Okay, so what you can do is 2017. Okay, 2017 minus this, it will get minus 1. 2017 will move here as only. Okay, this one minus 1 by 4 minus 1 by 4 square until so on. What is the last term? Minus 1 by 2016. Okay, and this will be what? Minus 1 by 4 2017. Now here the last term is similar to this, so we can consider it in this. Okay, in this as a GP. Okay, you don't need to exclude it. Okay, so this thing teaches you only questions. Okay, no theory can tell you this. Okay, so depending on the problem you need to be very alert. Okay, this thing will be also be included in the GP. Okay, now we will calculate the GP. 217. I will take 1 by 4 common. Okay, 1 by 4 common, which gives me what? 1 plus 1 by 4, 1 by 4 square till what? 2016. Okay, so if I want to calculate the sum, it is nothing but 1 by 4 taken common, 1 minus 1 by 4 power 217. Okay, it is very simple, it is 217 terms upon 1. Okay, it is what? Plus, okay, plus 1 by 4. Okay, so what we can do? Okay, what we can do? Plus minus 1 by 4. Okay, so it gives me what? Okay, so it gives me Okay, nothing is going wrong. Okay, so if I calculate this 217, okay, what I get, minus 1 by 4 into 1 minus 1 by 4, 207 upon 3 by 4, 4 will cancel out. Okay, so this will become 3s by 4 further on, and this we have 217 minus 1 by 3 into 1 minus 1 by 4 power 2017. Okay, so here if I multiply these things, okay, what I get, 2017, okay, into 4 by 3, and here if what I get, 4 by, okay, 4 by 6, 9, 4 by 9, 1 minus 1 by 4, 0, 2017. So you need to be very alert, okay, in solving these problems. Okay, so this was the calculation stuff. Okay, now we are done with this problem. Now let's move on. The thing was calculation. After this, okay, this was a decreasing AP. Okay, you know the last one, and you need to be alert with the TN term of GP. Okay, after you do that, this rest is very easy. Okay, this problem was very amazing. Okay, now let's move on to the next problem. The next problem is this 8th problem. Okay, the 8th problem says 1 plus 2 into 1 plus 1 by 50, okay, plus 3 into 1 plus 1 by 50 the whole square, okay, and so on till 15 terms. Okay, find the sum. Okay, so the sum we need to find out. Now one thing you can easily understand by observing the series, that if I let 1 plus 1 by 50 be what, some k, okay, then the s will become what, 1 plus 2 plus k square, and so on till how many terms, 50 terms. K power will be what, 49, okay, because 0 then 1 0, then it will be 50 terms. Okay, so k power 49, then k power 49 into k 48, and so on. Now if I multiply it by k as what I get, 1, this will become what, k, 2k square, 3k cube, and so until 50. Okay, let me call it as 2. So what I get next, okay, next I get 1 minus k into s after subtracting 1 minus 2, 1 plus k square till k power 49, okay, minus 50 k power 50. Okay, this is the thing. Okay, after doing this step, okay, what you can came to know that 1 plus, okay, if I take k common, okay, what we can do, these are nothing but, okay, these are all 50 terms. Okay, 1 2 3 4, okay, this term is also included. So 1 is the first term, 1 minus k, the common ratio is k upon what, 50 terms upon 1 minus 1 minus k. Okay, so 1 minus k, this is the thing which we got, up minus 50 k power 50. Okay, now if we substitute the value, what we get, this is nothing but 1 minus 1 plus 1 by 50 s. Okay, you need to be alert at what point you need to substitute the k. Okay, so 1 minus 1 plus 1 by 50, the 50, 1 minus 1 plus 1 by 50, okay, minus 50 into 1 plus 1 by 50, the whole power 50. Now you can clearly see that this will cancel out, which will give me minus 1 by 50 will move here. Okay, this will be 1 minus 1 plus 1 by 50, okay, the whole power 50, minus 50 into 1 plus 1 by 50, the whole power 50. If I multiply this with this, okay, what I have, minus 50 plus 50 into 1 plus 1 by 50, the whole power 50, minus 50 into 1 plus 1 by 50, the whole power 50. So these two are cancelling out. Okay, if you observe, these two are cancelling out, and here what I am left with, minus 1 by 50 s. Okay, now if you observe, okay, in the next page, the minus will cancel out. What I get, 50 power 50, the whole square will give me s is equals to 2500. Okay, so this is our answer. Okay, so in this type of problem, when some common terms, okay, such like irrational terms are given, okay, you need to consider them. Okay, like 1 plus 1 by 50, consider it as some p, k, q. Okay, and at the exact point after getting the sum, you need to substitute that. Okay, and it was giving 50 terms. Okay, so there was no point in finding the tn of ap, gp. Okay, okay, and then we just did the normal method and calculated it. Okay, now let's move on to the next problem. Okay, the next problem is this: find the sum of infinity series. Infinity of the series 1 minus 3x plus 5x square minus 7x cube till infinity. Okay, so it is very general problem. Okay, they have given a very general problem. Okay, so what we can do: don't take the AP in negative. Please don't take the AP negative, take the GP negative. So here what I can take the common ratio as what? X minus X. Okay, I can take the common ratio as minus X, but here the GP what I will take AP. AP will be nothing but 1 3 5 7. Okay, don't take the, so here you can clearly see when that X is odd you get minus. Okay, so my sequence is what? 1 minus 3x plus 5x infinity series, so don't need to get the tn term. Okay, multiply it by what? Minus x. Okay, until so on infinity, call it as 1, it is still infinity, call it as 2, subtract this, what I get? 1 minus x into s. Okay, what I get? 1 here will be as it is, minus into minus, minus 2x. Okay, this will become plus 2x square, this will become minus 2x cube, this will become, okay, plus 2x cube, x power 4. Okay, this will be x power 4 till what? Infinity. Now if I consider this and move 2x outside, what I have? 1 minus x, okay, plus x minus x until so on infinity. Okay, what I get? 1 minus 2x upon 1 minus x. Okay, which gives me what? 1 minus 2x upon 1 minus x. If I multiply 1 minus x minus 2x, okay, okay, let me check. This is minus x. Okay, so it will become plus x. Okay, so this will be plus x upon what? Upon 1 plus x. Okay, are we doing any mistake? Okay, 2x 1 minus x. Okay, minus 2x we took common, minus x square, 1 upon minus x we took. Okay, do we need to 1 minus x plus x? Okay, okay, wait a minute, it is not a GP only. Okay, here if you observe, all the powers are same. Okay, it should be like this, x square, x cube. Okay, like that till infinity. Okay, now if you see, minus x power will be there. Okay, so minus x will become plus x. Okay, common ratio will become plus x. So if I multiply it, okay, what I get? 1 plus x minus 2x upon 1 plus x. Okay, let me check we are doing any mistake or what. So we are not doing any mistake because all the things are proper. Okay, so the answer is 1 minus x upon 1 plus, okay, 1 plus x. Okay, this is 1 plus x. Okay, now okay, we did a mistake here. If I have taken minus, if I subtract it again, it will become 1 plus x. Okay, so what we are getting? 1 minus x upon 1 plus x the whole square. Okay, now the thing, because I was confused, is that 1 minus x, here I am getting 1 minus x, but here I am getting 1 plus x, so they are not same. Usually they are same. Okay, so in this way you can cross verify your problem's answer. Okay, so this was the 9th problem. Okay, let's move on to the 10th problem. Okay, nothing great was there. Okay, you just need to be don't get scared of alternate minus signs. That's it, this question I want to tell you. Okay, common ratio you always take negative, that is normal. Okay, you have learned this thing also. Okay, now let's move on to the next problem. Okay, let me get the next problem. The next problem is this problem. Okay, which says find the sum of the infinite series. Okay, now if I consider it as s1 plus 1 plus 1 by 5 into 1 by 2 plus 1 by 5 plus 1 by 5 square into 1 by 2 square till what? Infinite. Okay, now what you can see, what you can observe, that is very crucial. There is no need of considering something, okay, here, because it is increasing usually. So I know the common ratio is nothing but 1 by 2. Multiply it by 1 by 2. What do you get? 1 by 2. 1 plus 1 by 5 is nothing but 1 by 2 square, until so on till infinity. You call it as 1, this you call it as 2. Subtract it, what you get? S by 2 again. This is 1 and this is 1 by 2. You get 1 by 2 again. 1. This will 1 will cancel out, giving you 1 by 5 into 1 by 2. Further on you get 1 by 5 square into 1 by 2 square. You get 1 by 5 cube into 1 by 2 cube, until so on till infinity. Okay, now if you observe, this is nothing but 1 by 10, this is nothing but 100, this is nothing but 1000. So it is forming a GP again. 1 plus, if you take 1 by 10 common, this is nothing but 1 plus 1 by 10 till infinity. Okay, so what you can do, 1 plus 1 by 10 into 1 upon 1 minus 10, 1 by 10. Okay, what do you get? 1 plus 1 by 10 is nothing but 10 minus 1, 9. 9 by 10, 10, 10 will cancel out, giving you 9 plus 1 upon 9, which is nothing but 10. 10 by 9. So if you observe, it was S by 2. Okay, it was S by 2. So S by 2 will move there, it will give you 20 by 9. Okay, so this is our answer. Okay, so the thing is that here you should understand that after getting some particular number, you in some cases you should multiply also and check what kind of GP. If I have 1 by 2 5 as common, then it would have been difficult to analyze. Okay, so just try to, sometimes when something like product in form, try to get the product is also a GP like this. Here it is forming a GP, so we can calculate it more easily. Okay, that is all this question I want to teach you, nothing much. Okay, now let's move on to the next question. Okay, this is a new variety type problem. Okay, they will give you the sum value and they will tell you to find the sum. Let me read the question. If the sum of the infinity of the series 3 plus d into 1 by 4 plus 3 plus 2d into 1 by 4 square till infinity is 44 by 9, then find d. You want to find the d. Now I will call it as S. 3 plus d. I know it is 1 by 4 ratio, and till what? Infinity. I will call it as A. This I will multiply it by 1 by 4, 3 by 4, 3 by d, 1 by 4 square. Now I don't need to write much. Call it as B, subtract it, get 3s by 4. What you get? 3 will come out, this 3 will cancel with d by 4, d by 4 square, d by 4 cube. Okay, now you have observed the pattern. Now get on to the basic thing, which is that get the d by 4 common. 1 plus 1 by 4 plus 1 by 4 square, and so on till infinity. Then what you get? 3 plus d is what? Okay, d is what? Find d. Okay, we need to find the d only. Okay, they have given the sum. Sum is nothing but 44 by 9, which is nothing but 11 by 3. Okay, 11 by 3. Okay, 11 by 3 is the sum. Okay, d you need to find out. Okay, you can get the sum as 1 upon 1 by 1 minus 1 by 4. Very easy. 3 plus d by 4 into 4 by 3, which gives you 3 plus d by 3. Okay, this is nothing but 3. If I multiply it, what I get? 9 plus d, and here 11 is present. So can I get the d? D is nothing but 2. Okay, so I got my d. Okay, so the problem was just to find the d value. Okay, just to let you see some new variety. Okay, nothing much. Okay, now let's move on to the next problem. Okay, the next problem is question number 12. Okay, the question number 12, okay, is as follow. Okay, which says find the sum of the infinity of the series 1 square plus 2 square x plus 3 square x square plus 4 square x cube till infinity. Okay, now let's get the sum of this. Okay, now you can see 1, 4, 9, 16. Okay, like this term. 4 minus 1 is 3, 9 minus 4 is 5. Now you are very familiar with this pattern. 16 minus 9 is nothing but 7. Now 5 minus 3 is 2, and 7 minus 5 is twice AGP problem. Okay, it is very easy. We have seen this variety twice, AGP application problem. Okay, so what we will do, get what is the common ratio, x multiplied by x. Okay, call it as a only. 1 plus 2 square x square. Okay, this will become x, this will become, okay, x square, and this will become x cube, this will become x to 4 till infinity. Call it as b. Okay, I will call it as way to avoid some useless word. So 1 minus x into s is nothing but 1 plus, this will cancel out with this 3x. Okay, 3x. Similarly with this will cancel out with this, giving me 5x square. Okay, next 7x square. Okay, x cube, and so on till infinity. I will call it as some p. P is nothing but 1 plus 3x plus 5x square and 7x cube till infinity. Okay, I will call it as again some c. I will multiply it by x into p, me x plus 3x square, 5x cube, so on till infinity. I will call it as d. C minus d is nothing but 1 minus x into p. Okay, so we are getting this equation. Okay, now after this equation, okay, this is the thing, 1 plus, okay, 2x 2. If I take 2x common, what I left with 1 plus x square, and so on till infinity. Can I get this sum? Yes, 2x upon 1 minus x. Okay, which gives you what, 1 plus 2x upon 1 minus x. If I multiply it here, 1 minus x plus 2x upon 1 minus x, which gives me 1 plus x upon 1 minus x. Okay, so what we can do, if I move this 1 minus x here, what I get, 1 minus, okay, 1 minus 1 plus x upon 1 minus x the whole square. Okay, so we got the p thing. Okay, now what we can do, replace the p thing. Okay, replace the p with the s. Okay, what was p? P was nothing but 1 minus x into s. Okay, if I replace this by this, what I have, 1 minus x into s is nothing but 1 plus x upon 1 minus x the whole square, which gives me s is equals to 1 plus x upon 1 minus x the whole cube. Okay, so I got my s. Okay, so this is all this problem was about. This is nothing new. Okay, I have told you already all the things about this type of problem. Now let's move on to the next problem. Okay, the next problem is this problem. If the alpha is the nth root of unity, then prove that 1 plus 2 alpha plus 3 alpha square and so on till n terms is equals to minus n upon 1 minus alpha. Now there is nothing you need to know, just know this alpha power n is nothing but 1. Okay, there is the property of nth root of unity. Okay, you will study in complex root, just know this, that alpha power n is equals to 1. Okay, how it appears, okay, x is equals to 1, then n power, okay, like that stuff. Okay, you will study in complex number. I am telling you, this is the last topic, I guess. Okay, so if alpha is the nth root of unity, then prove that 1 plus 2 alpha plus 3 alpha square till n terms, okay, is minus n upon 1 minus alpha. Now if you observe, it is in AP, this is in GP. I will just multiply by alpha. What I get, alpha plus 2 alpha square, okay, plus 3 alpha cube, and so on till n term. Okay, here I need to get my Tn term, 1 plus n minus 1 into 1, which gives me my n term. And okay, my GP Tn term is nothing but 1 into alpha power n minus 1. So it is nothing but alpha power n minus 1, nothing new. Okay, n into alpha power n minus 1. Okay, so if I multiply it by alpha, okay, what I get, n by alpha, n into alpha power n. Then if I subtract this, what I get, 1 minus alpha power s. I will call this series as s. What I get, 1. Okay, this I get alpha square, alpha cube, till what, till alpha power n minus 1, and the last thing is alpha power n. Okay, now here if I calculate its sum, what I get, okay, if I calculate this whole sum, what it is equal to, okay, what it is equal to, first term is 1, okay, alpha power n terms are there total, from 1 to 3 it is n minus 1, and here it is 1, so alpha power n, okay, sorry, 1 minus alpha, because it is 1 minus alpha power 1 into 1 minus alpha, okay, minus n into alpha power n. Okay, so what I am getting idea that alpha power n is 1. Okay, so I am substituting that 1 minus 1 minus alpha into n into alpha power n is nothing but 1. Okay, I will substitute that. It is equal to 0 and this is nothing but n. If I move this here, what I get? 1 minus alpha. So hence proved. It is equal to minus n upon 1 minus alpha. If I substitute it becomes 1, 1, 1 minus 1, 0. Okay, the left thing is this, which will be minus n. Okay, which will be divided by 1 minus alpha gives me the solution. Okay, nothing much. Okay, the previous thing only. Okay, we are just moving around in the same thing only. Okay, doing same thing again and again. Okay, but I need to make you very sure in AGP that you have solved decent number of problems. Okay, that is the main target. Okay, so the 14th problem is find the sum of the n terms of the series 1 plus 4 power 5 plus 7 by 5 square 10 by 5 cube and so on till, okay, it is still n terms. Okay, common ratio is very easy to understand. It is 1 by 5. Okay, 1 4 7 10. Okay, it is 3. Difference is also very clear, 3. So all you need to know, if it is s, then what I have? Okay, you need to calculate the tn. Tn will be what? 1 plus n minus 1 into 3, which gives you what? 3n minus 2. Tn will be what? Will be 1 into 1 by 5 power n minus 1. So my s, okay, tn term of AGP is nothing but AGP, arithmetic geometric progression, is 3n minus 2 into 1 by 5 power n minus 1. Okay, now here if I multiply it by 5, okay, and then write what I get: 1 by 5, 4 by 5 square, 7 by 5 cube till so on. What will be my last term? 3n minus 2 upon 5 power, okay, n. Okay, now similarly if I subtract that, what I get? 4s by 5. Very simple. 1 plus this will cancel out with this, give me 3 by 5. Okay, this will cancel out with giving 3 by 5 square, 3 by 5 cube till what? 3 by 5 power n minus 1 minus 3n minus 2 upon 5 power n. Okay, now after this what we can do? Take 1 plus 3 by 5 common, which gives me what? Okay, 1 plus 1 by 5, 1 by 5 square till what? 1 by 5 power n minus 2. Okay, what I get after this? 3n minus 2 upon 5n. Okay, after this what I get? Okay, what I get after this? I get a simple thing, okay, which is nothing but 1 plus 3 by 5 is nothing but what? 1 by 5. Okay, what we can do here is, it is what? n minus 1 terms. Okay, it is n minus 1 term, 1 minus 1 by 5 power n minus 1 term upon 1 minus 1 by 5. Okay, and here it is what? 3n minus 2 upon 5 by n. Okay, and this is what? 4s by 5. Okay, very easy. Okay, now if we move this that side, okay, this is previous problem. Okay, so what we can get? So here if we calculate it further, okay, 5 will cancel out, 3 will be here. Okay, 1 minus 1 by 5 power n minus 1. Okay, 5 will cancel out, here it will be what? 5 minus 1, 4, and this will be nothing but 3n minus 2 by 5 power n. Now let's move this 4 by 5 here. What I get? S is equals to 5 by 4 I will get. This will become 15 by 16 into 1 minus 1 by 5 power n minus 1. This will become what? 3n. Here if it will be 5, if I move it down, I will get 5 power n minus 1, and here if I can move it down, okay, nothing doesn't matter, 4 will be in the multiplication. Okay, so this is our answer. Okay, nothing new, just calculation part was different. Okay, everything was same in like the previous problem. Okay, now let's move on to the next problem. The next problem is this. Okay, I think we have done this problem or what? Okay, but let's do it again. Okay, do it again. We have done this problem. 1 plus 2 square. Okay, I have to check, but I don't have. Okay, if it is s, I know that okay, it is just twice application of AGP. Okay, we have done this problem, okay, with different number, I guess. Okay, with different number means, okay, we have done this problem. Okay, we have done this problem. This was similar to 14th problem. Okay, You can do it as you with yourself. Should I do it? Okay, let's do it. Okay, analyze the terms. 49. Okay, now what do you get? 8 difference. This difference is what? This difference is something else, like 9 minus it is nothing but 16. Okay, and this difference is even more bigger than this. It is what? 15 plus 9. Okay, 24. Okay, 24. Okay, now if you check 16 minus 8, it will be nothing but 8. 24 minus 16, it will nothing but 8. So it is a twice AGP type problem. Okay, call it as S multiplied by 2. What you are getting? 1 by 2 square, 3 square by 2 power 3, and 5 square by 2 power 4, and so on till infinity. If I subtract, call it as B, this call it as A, subtract it, what you get? S by 2. Okay, then what you get? 1. Okay, this will become what? 3 minus 1 means 8 by 2 square. This will become 25 by 2 power 3. This will become 49 by what? 49 by, okay, sorry, 20. This is okay, this is 16. This will become 16. This will become 24. Okay, 24 by 2 by 4. Sorry for the bad writing. Okay, and here we are getting this thing. Okay, after doing this, what I can get? Okay, we are getting this is some new thing. Okay, I will call it as some P. 1 plus 8 by 2 square, 16 by 2 by 3, 24 by 2 power 4. Okay, still so on till infinity. Okay, I will multiply it by 2. What I get? 1 by 2, 8 by, okay, 1 by 2, okay, 8 by, we got this was 1 by 2 only. Okay, this was 1 by 2. Okay, so what we can do? This will become 1 by 2 square, this will become 1 by 2 cube, this will become 2 power 4, and so on till infinity. Now if I subtract this, I will again get P by 2. Okay, what we are getting? 1 by 2 will come out like this. Okay, okay, what we can do in this problem? Okay, let me check. Okay, so the thing which we are doing wrong is that here, if you observe clearly, this is in GP, this is not in GP. Okay, it is not also in AP, so we need to get this separately. Okay, this thing we need to get it separately. Okay, okay, so considering it all as P is wrong. Okay, this problem is little different. Listen what I am telling. The S by 2 was this: 1 by 2, 8 by 2 square, 16 by 2 by 3, 24 by 2 power 4 till infinity, right? Now this is in GP. Okay, this is some, okay, this is not in GP, so we will call it some P. Okay, we will call it some P. 8 by 2 square. Okay, that's why it was not cancelling out here. 2 by 3, 24 by 2 by 4, until infinity. Now we will multiply it with the common ratio, which is nothing but P by 2. Okay, which gives me what? 8 by 2 cube, 16 by 2 by 4, 24 by 2 by 5, until infinity. If I subtract this, I get P by 2. It is nothing but 8 by 2 by 2. This is nothing but 8 by 2 cube, and so on till infinity. If I get 8 by 2 by 2 common, what I 1 upon 2, 1 upon 2 square till infinity. What we can do? 8 by 4 gives me 1 upon 1 minus 1 by 2, gives me what? 2 into 1 upon 2 minus 1 by 2, which is nothing but 4. So we are getting 4 into 2. P2 will move there. Okay, so we get P is equals to 8. After getting P is equals to 8, what is our S by 2? Okay, S by 2 is nothing but 1 by 2 plus P, which is nothing but 1 by 2 plus 8, which is, if I multiply it by 2, what I get? 1 plus 16, which is nothing but 17. So 17 is our answer. So S is equals to 17. The difference in this problem is that at this point you need to understand that this is only in GP while the rest part is in, okay, it's something different. Okay, so you need to find it separately. Okay, that is the trick in this question. Okay, hope I did it, because if you have thought it like that only, okay, then it would have been difficult for you. So this is some different type variety. Okay, so I have told you many varieties. Okay, and rest we will see while solving examples in problem solving. So then we are done with AGP and we will move on to sigma properties, okay, in the next lecture. Till then, take care. See you in the next lecture.